mass and temperature. So again, like we did last week, last Wednesday, I have some pictures that I want to make sure everybody kind of gets a grasp of what goes with what as far as the picture and what we're going to be measuring with. So with grams, we're going to be weighing things. So you have to think of the weight of certain objects. So if we're trying to weigh a baby, what do you think we're going to be using as far as the units? So just go ahead and pop into the chat box and put down the answer. If you think it's going to be kilograms, grams, tons, and you can abbreviate, you can just put G, kg, tons, or milligrams, or mg for milligrams. Just like on a quiz on a test, they're going to have some objects, and I got pictures, but they're going to have objects where you need to understand what you're going to be using. So if this, again, it seems really easy to you, this is the kind of things we're going to make sure we get right on the test so we can maximize our grading. So kilograms. So why is it kilograms? Everybody was putting grams. So let's kind of take a step back and think about grams. When we, I don't know, I used to do this when I was small with me and my sisters. We used to all sit around a breakfast table and we used to all pour ourselves some bowls of cereal. And we always like to read the nutrition part on the box. Does anybody do that? Hands if y'all read some nutrition while you're eating or something. Don't y'all see on there saying like fat has 14 grams of fat and sodium might have milligrams. Think about if the cereal has 14 grams of fat, how much do you think that weighs? That 14 grams of fat in that candy bar that you're eating or something like that. Really, really small, right? Really tiny. So this is why a baby that weighs a lot more will be kilograms instead of just grams, if that makes any sense to everybody. Hopefully. But yes, I do see what you mean. As far as grams, you thinking the baby being so small. But once again, if you think about 1 gram, 1 gram of this, just look on some of your nutrition bars and see how many grams of this is in that nutrition. You know that nutrition stuff is weighs a lot less than a baby eating it in by portion. So now we're thinking about this tiny little bee now, real tiny. What would this be measured in? So we get a lot of milligrams. I think the first person I got on said grams, which this one will be milligrams, so it's really, really small. Um, Also, too, once you kind of see the conversion of how to convert like kilograms to pounds, you kind of see that the baby will be addressed as kilograms than grams or milligrams or so. So we think about a train now. And this one's pretty much easy. This is all going to be metric tons, which is good. What about a refrigerator? So we got some kilograms, we got some tons, we got some more kilograms. This one will be kilograms too. So to kind of help you out to understand the difference between kilograms and everything else is if it has some pounds to it, then we're going to notify that's kilogram. Kilograms is pretty much the same thing as working with pounds. So if you have something that you need to weigh in pounds, like on a scale or something, then we're going to be using kilograms. If you cannot lift I like something that's metric in tons, that means you can't lift it by hand, or any kind of man or female cannot lift this by hand. That's what we're talking about, tons. So if you look at an object and you feel like it can be lifted, now obviously we can't lift a refrigerator, but if you use a dolly and roll it in, we can still get it in. But we cannot going to put a dolly up on a train and be able to move it. So anything we can't move is going to be tons. If we need to weigh it on pounds, then we're going to be using kilograms, or for pounds, we're going to be using kilograms. So the last one, Frosted Flakes, I'm not necessarily, yeah, so the box of Frosted Flakes with, we'll just say the cereal inside of it. Let me go ahead and just put this there. You don't have to worry about the chat box. This will be actually grams. The frog is really, for here, I don't, yeah, obviously a frog is bigger than a bee, so we're just going to say a big toad, and we're going to say that's grams too. So hopefully by looking at these pictures, you can kind of get an idea of what goes with what when we're trying to measuring certain objects in real life. So one of the tips or helpful conversions that you would need to know is the last one down here, 1 meter, cubic meter is equal to 1 kiloliter, which is equal to 1 ton. So kiloliter, as far as the volume, is equal to 1 ton. And remember, a kiloliter is the same thing as saying 1,000, so that's why it's equal to that 1 ton. So this is one of the, and I'll show you an example where we're going to be using 1 metric ton is equal to 1,000 kilograms and show you how to convert that. All right, so this is the method I kind of came up with to help us with converting certain, because sometimes we need to go from pounds to ounces or from gallons to cups and stuff like that. So, and this is a good method. And if you have your own method, that's fine. I'm just trying to give everybody just one of those methods that's going to help us. So I have the numbers laid out before what you need to fill in first. So the first thing you do with the cross method is you want to draw a cross. The bottom left-hand corner, you can leave empty. You don't have to put anything there, just leave it empty. But however, number one, this is where you need to put what's given. So when you read the word problem, they give you something as far as and to start off with. So it's something like, let's convert 5 miles into feet. What was the given part? 5 miles will go into the top left-hand corner. So the second thing you need to fill in is the number 2 spot, which is going to be the same unit as the given. So if I said 5 miles, the thing with the unit that we need to write down in the bottom left-hand corner is just miles. We're not writing a number, it's just the unit, which is miles. So I want these to match. Miles up in the left, miles down in the bottom right-hand corner. Those have to match. The reason why we want them to match is because when they're diagonal like that, they can cancel out. We want them to cancel out because we're going to something else. And what was that unit I said was going to? If I said 5 miles, we're going to feet. So up in the top right-hand corner is what we're going to, which in this case would be feet. So 5 miles was given in the directions in my MyFast Plus. Write down the unit only. So we put miles down here, bottom right-hand corner. And then what we're going to in the directions were feet. So just write feet. So you should have a number, and these two should be blank with just the 2 units. This part here on the right side is called unit fraction. With a unit fraction, the number 2 down here in the bottom left and the number 3, these units here should always be equal to each other. So this is where we actually go to the conversion in the book or a chart that I have laid out in the Moodle or whatever the case to be, that you need to have off to the side when you're testing, so you'll know this is actually equal to this. Does anybody know how many feet actually equals into 1 mile? Type that in the chat box real quick. How many feet are in 1 mile? Don't go look it up. Don't Google it. Just want to see if you know. I see you free to try to go look it up. We're getting close. I think Frida has it. I want Frida to peek somewhere. So 5,280 feet will be the cover. So these are the conversions you need to have off to the side, because when the MyMathFast Plus or the test asks you to convert this and this, you need to know that conversion. So here is a problem in MyMathFast Plus. It says convert as indicated. We have 6.8 kilograms and we want to convert it to tons. Remember that little chart that I told you that's going to be helpful. Remember, 1 ton is over or is equal to 1,000 kilograms. So back to this. So right here, 1 ton is equal to 1,000 kilograms. So this is one of the ones you need to know and write down off to the side, because you're going to need that conversion. So looking up here, when we fill this out, the given part is going to be what? It's going to be the 6.8 kilograms. That's what we put in the top left-hand corner. Now, what do we put in the bottom right-hand corner? What did I say to put? Just the what? Right, Jonathan, it's the kilograms. Remember, Shelby, we're not putting the actual number here. We're just putting just the unit that's in the top left-hand corner as a given. So if there's kilograms here, there's going to be kilograms down here. Don't write the number 6.8. But 6.8 does, I think, Shelby, you was probably talking about the given part when you told me 6.8 kilograms. So I put the kilograms here, kilograms here, and then I noticed the kilograms beside it is 1,000. So that's where I write my 1,000 at. So 1,000 kilograms. So what am I going to? I'm going to tons. So that means in the top, I'm going to put tons. So 1 ton over 1,000 kilograms of this part goes inserted as my unit fraction over to the right side. Now, this is where the math comes into play. If there's a 1 on top, then in the number, the actual number is on bottom. Because notice when you do a lot of conversion, you'll always see 1 is equal to this, 1 is equal to that. If you have the 1 on top, you can ignore what's on top and just divide these two. So if the number's on the bottom, if you want to write this sentence, if you have the number on the bottom of the cross method, you always divide. If the number is on the bottom of the cross method, you will always divide. So you just take 6.8 divided by 1,000. The second sentence that that you can write down right underneath it is, say that if it's flip-flop, sometimes the 1 will be located in the bottom right-hand corner, and then the numbers will actually be on the top. So if you see the number, both numbers are on top, you multiply. So pretty much you're always kind of ignoring the 1. Just look for the other number. It's either going to be, a different kind of conversion. I'll kind of show you in another chart in 7.4 where that number should be. So two numbers on the, if it's crossed like this, divide. If the numbers are on top, side by side, all up in the top part, you multiply. So if you divide these two, we should get 0.0068 metric tons. So the next part of this section, we're going to actually be talking about what if it's square, like if you have centimeters squared, meters squared. We talked about last week how to move the decimal, but if it's squared, there's one little sentence that you need to write in your notes about if it's squared. When we're working with square units, the number of times you normally will move the decimal, it needs to be doubled. So what do I mean by that? If the squares wasn't here, if I was going from centimeters to meters, so centimeters to meters, do y'all agree that I'll move it 2 times? 1, 2. If I did not have the square up there, everybody agree you move it to the left 2 spots? Can I get everybody thumbs up, shaking heads? Yes? Okay, great. Because you have a square up here, you need to automatically double it. So instead of moving the decimal 2 times, you move it 4 times. If you move the decimal 3 times, you have to move it 6 times if you're doubling it. So anytime you're working with a square unit, you need to double the number of times you move the decimal. So once again, I think where's my chart? So once again, for this first part, the decimal is located at the end. I know that if I'm doing normal metric units, I'll go 1, 2 times, but since I know it's going to be double, I got to move 4 times. So if it's at the end, I'm going to go 1, 2, 3, 4. So if I'm going centimeters to millimeters, how many times we move it? This one we move it 1 time. So if I want to double that, I'm going to move it 2 times. So once again, the decimal is located at the end. And I'm going to move it 2 times. 1, 2. And that's why I add another 0 there. 2 zeros and put the decimal at the end to get square millimeters. So these here, we're going to be from Celsius to Fahrenheit and from Fahrenheit to Celsius. And there's not really much that we need to kind of know about these two. Obviously, you just need to know the formula. And again, you will have this access for the formula part. So if you don't hit converting 55 Fahrenheit to Celsius, Celsius to Fahrenheit for me. So we need to use this one. Make sure you use it in your calculator parentheses, a fraction in parentheses shown. And for 60, you will place it here in Fahrenheit. So if you don't mind giving us and put it in the chat box what the answer would be for Celsius and Fahrenheit. Please put F and C right beside it. I know the answer for each. So you should have 12.8 degrees Celsius and then 140 degrees Fahrenheit for both of your answers. So if you have one of those wrong, maybe it's just making sure you be careful how you place it into the calculator and getting your answers. So for 7.3, there are no bookwork that you need to turn in. Nobody's shouting hooray, so I'm thinking y'all disappointed that there is no bookwork. So I think I need to give bookwork. I'm just kidding. So that's going to conclude the answer for the section 7.3.